Hello again, this is another COVID-19 tribute lecture. A few more thoughts on task analysis. This lecture will be about 5 minutes, I figure. Eliel Saarinen, the famous Finnish architect, always said, always design a thing by considering it in its next larger context. A chair in a room in a house in an environment in a city plan. Sort of the same thing is true for software. And before you even set into the design, during the task analysis phase, you also want to think about the larger context. So we talked about the missile defense system, the SAGE system, where they sort of forgot about the moon as part of the context. We also talked about the system for scheduling the patient test in the hospital, where they forgot about the larger context or what's actually happening in a hospital. If you're designing a printer, what's the larger context? It's things like where the people get the paper, where they walk from their desk to pick up their printouts, where they set the paper before they pull out the tray to put the new paper in. If you think about the larger context of use, you can make more informed design decisions. And these are the reasons we do ethnographic observation and similar techniques. All right, so one good way to do a bad job of task analysis is by not thinking about the larger context. Another is to idealize things. That's also known as premature abstraction. You forget the details. So for example, picking courses for your next semester in college. Well, we can just say that mathematically it's the intersection of finding the set of all the courses on the degree plan with the set of all courses at convenient times. It's a beautiful, elegant, high-level mathematical description, but almost completely useless. The details are what matters. Another way to do a task analysis poorly is to focus on a technology prematurely. What happens if, like 15 years ago, the people at Apple had said, you know, what we need to do is we need a new invention where we make computers like really small and we put antennas on them, and that way people can use them to make phone calls. Well, they certainly wouldn't have invented the iPhone. What they did was they focused on what people would do with a device and thought about how they would use it. And based on those things, they designed the user interface first, and then later they worried about what kind of computer and how big the antenna should be and how that should be packaged. All right, so here we go. Little question for you. So first I need to explain what is a solution-neutral problem statement. So before you start a design, you should figure out what is the problem you're trying to solve. Otherwise you'll solve the wrong problem. That statement of the problem should be solution-neutral. That is, it shouldn't presume some specific way to solve the problem. So here's 5 different ways you might describe a problem to solve. And I'd like you to go through those and pick out which one is an appropriate, solution-neutral, but still useful problem statement. I'll give you 10 seconds. What do you think?
The third bullet point?
The third bullet point, devise a means for inputting and viewing structured information regarding beer and wine inventory, right? Yeah, that's not crazy abstract, but it's not super descriptive, right? This one here, the first one, is clearly not solution neutral. It tells exactly how you're going to build it, right? At some phase, you may come up with that part of the design, but when you're defining the problem, you probably want something like this, or maybe like this. It's hard to say in general what's the exact right level, but you do want to strive to be solution neutral when you describe the problem you're trying to solve.